Hi ladies, this is lesson 11.1. This is geometry of solids. Now in this lesson there are just a lot of vocabulary terms. So I mentioned this during class, but please make a Quizlet or make flashcards or have some way to organize all of these terms. A lot of them are shapes. Some of them are terms related to the parts of a solid, and we'll go over a couple of those in this lesson. But it's a lot about just identifying the shapes. Now in this first lesson, we're going to look at cross sections. So again, all of these are on your vocabulary chapter 11 handout where they're defined, there's pictures. So again, do what you do for other classes to learn your vocabulary terms. You're not going to have a quiz on the vocab terms, but they will appear in questions. So you need to know what the question is asking. In order to identify what the question is asking, you need to be familiar with these vocabulary terms. So in this lesson, we're looking at cross sections. So the cross section, and we looked at this in the first semester, but it's the two-dimensional result of slicing a solid. So the plane that results from slicing a solid, you can take a cross section straight up and down, you can take it straight horizontally, or you can take it at some kind of angle. But it's a two-dimensional figure that you get from slicing a solid by a plane. So let's look at these cross sections. So these are all right solids, which means that they stand straight up and down. So the base and the top of the solid are perpendicular, or are parallel and perpendicular, and you can draw the height perpendicular to them through the center of the base and the top, or the two bases. So looking at this first cross section of a cube, if you think of a cube, there are squares on all four sides. So the first thing that might come to mind is a square. Maybe you can slice it diagonally and you'll see that you get a rectangle, but there are a ton of different cross sections for cubes. So the first one you might think of is a square, but again, if you cut it diagonally, you can get a rectangle. If you cut off just one of the corners, you can get a triangle. If you cut it at an angle, you can get a trapezoid. And then again, cutting it at an angle, you could get, depending on where the edges of your plane lie, you could get a pentagon or you could get a hexagon. So all of these are cross sections of a cube. You're going to get the same kind of cross sections if you take a rectangular prism, because a rectangular prism compared to a cube is just taller. So looking at a triangular prism, again, you can get a rectangle if you slice it right here like we did in this blue figure. You could get a trapezoid. So this is slicing it at an angle. Or if you slice it straight in half, you could get a triangle. With a cylinder, you could get a few different shapes. You could get a circle if you slice it straight horizontally. If you slice it at an angle, you could get this oval shape, which we call an ellipse. And then if you slice it vertically, you could get a rectangle, or depending on how tall your cylinder is, you could potentially get a square too. A cone, you can get a few different things. You can get an ellipse, slicing it at an angle, which is an oval. You can get a circle. You could get a parabola shape. But a sphere, no matter which way you slice a sphere, you are only going to get a circle for the cross section. Now the cross section for all of these solids that are not right solids, but instead they're oblique, which means they're at an angle. So these are just a few examples of oblique solids. So this would be an oblique cone. This would be an oblique cylinder. This would be an oblique hexagonal pyramid. Here's a right prism, a right pentagonal prism, and here's an oblique pentagonal prism. So all of these solids, they're at an angle. So the segment that would go through the center of the base and the top is no longer perpendicular to the base. Okay, it's at a little bit of an angle. Now the cross section for these oblique solids is exactly the same. So between oblique solids and right solids, there is no change in cross sections, because any cross section we take, we can just take it at an angle. So if we take a cross section here of this cone, this oblique cylinder, if instead of going straight across, when we go straight across, we'll get an ellipse. But if we go at an angle, we could get a circle. So all of the cross sections formed are exactly the same, whether the solid is oblique or a right solid. Right, so now here's a few applications of our vocabulary. So here we're looking for all the lateral faces. The lateral faces are the faces that go up and down. In this case, all of the lateral faces are triangles. So in this example with a square pyramid, pyramids are defined by their base. So this pyramid has a square base, but all of the lateral faces are going to be triangles. For any pyramid, your lateral faces are going to be triangles. So when we identify our lateral faces, here is what we're looking for. We're looking for this triangle. So when we name triangles, we name it by their vertices. So to name all of these triangles, we would have EAD, EAB, EBC, ECD. You would have 4 triangles. So here are your 4 triangles. Now the lateral edges, those are the edges that connect the vertex to the base. So again, you have 4 edges, 1, 2, 3, 4. Those are the ones that connect the base to the vertex. And those are all segments. So when we name our lateral edges, we're going to name those as segments. Next, you have a vertex. And the vertex of a pyramid is that tip of the pyramid. The vertex of a cone would be the top of the cone. So our vertex is just that point E. And then lastly, the base, and again, the base of a pyramid, or the name of a pyramid is defined by its base. So we need to name that square, which is A, B, C, D. And then lastly, your closing question. So this is looking at that vocabulary term cylinder. Do any of these fit the definition of cylinder? And the answer is no. Because a cylinder has 2 congruent circle bases. Which none of these do. The only one that has 2 circles as a base is this one, and these 2 circles are not congruent. This one is almost a cylinder. It's only half of a cylinder though. We need this other half of the base in order to make this a complete cylinder. This one, not a circle, not a circle. So a cylinder is defined as having 2 congruent circle bases. So again, this lesson is a lot of vocabulary term. As we get into this chapter, we're going to look more at volume. But in order to do that, we need to be able to identify our shapes first so that we can associate the appropriate formulas for each of those solid figures. So please let me know if you have any questions, and I will see you in class.